Welcome back. In the last video we learned a few little arithmetic tricks, and we learned that arithmetic is a fancy word for mathematical operations that we can do on NumPy arrays. And so now we're going to learn a bit more about manipulating NumPy arrays through aggregation. Now, aggregation is another one of those fancy words. Let's Google it. Define aggregation. The formation of a number of things into a cluster. Yeah, that's kind of what we're going to do. So aggregation, performing the same operation on a number of things. And in our case, the number of things is our NumPy array. So let's have a look. You might be familiar with the sum method, so .sum or Python sum. So let's make a list. Listy list equals 1, 2, 3. Nice and simple. And we'll go type listy list. Listy list is not defined. Of course, we're making typos. There we go. Type Python list. So if we wanted to get the total of listy list, we could type in this. Sum listy list. And now that's a Python function right there, sum. But NumPy has its own version of these. So let's go back to our A1 array, which is a lot more trusty. Well, not a lot more, but it's just a different type to listy list, even though it contains the same information. It's in a type NumPy ND array. So let's have a look. What can we do with A1? We can call sum on it, and we get 6. We can also call np.sum on A1. We get 6 as well. Okay, now why would there be different functions here? And what is the main difference between these two? It can get confusing having two different ways to perform the same aggregation on a set of data. And remember, aggregation just performing the same operation on a number of things. Sum is just an aggregation to add up all the elements of a certain array or list. Now, the little tidbit you can use here is of which sum you should use, whether it be Python sum or np.sum, is use Python's methods on Python data types and use NumPy's methods on NumPy arrays. So this is sum. Actually, we might do this one in Markdown, so that's a bit easier to read. We don't want heading 1. We'll put this in code. So this is our tidbit, np.sum. There we go. Now let's see this in action. So we're going to create a massive NumPy array. Okay, massive array. This will really demonstrate the power of how fast NumPy can be. Remember how we talked about right at the start? We'll create a massive array with 100,000 different elements. This won't be too uncommon for machine learning problems. So there we go, .size 100,000. Let's just view, just so we can see what it looks like. Massive array. Let's view the first 100 elements. There we go. All random numbers, great. We might reduce that to 10 so we have a bit more space. Wonderful. Now we're going to use one of Jupyter Notebooks or Python's magic functions with, remember, a magic function has a little percentage sign at the start of it. And we got time it. And this is going to time how long a particular line of code takes to run. We'll try Python sum. So sum across massive array. We'll just put a little comment here. So Python sum, and then time it. We want NumPy's sum, massive array. And we'll put a little comment here, NumPy's sum. So let's run this and see what happens. Now it might take a little while because it's adding up 100,000 different numbers. So what have we got here? Well, the first line is going to be dedicated towards this line here. And the second line is going to be dedicated towards NumPy sum. So the first line, to sum over using Python sum across 100,000 different numbers, took 17.9 milliseconds per loop. plus or minus 2.94 milliseconds, 10 loops. But NumPy's sum, np.sum, put that there, np.sum, took 34 micro, this little symbol here is mu for microseconds. So let's convert that. We want microseconds to milliseconds. Equals 1 microsecond equals 0.001 milliseconds. So let's convert, this is milliseconds, we want to convert that to microseconds. 17.9 milliseconds actually to microseconds. There we go. So 17.9 milliseconds equals 17,900 microseconds. My goodness. So 17,900 divided by 34 equals 526. So that means NumPy's np.sum is 526 times faster than Python's sum. So going forward, remember the tidbit here. If you're working with NumPy data, use NumPy methods. But if you're working with Python data types, use Python methods. Because going back to the start, NumPy has been optimized to perform numerical calculations. So whenever you want to perform numerical calculations, always remember to use the NumPy version of an aggregation function. And speaking of aggregation functions, let's have a look at a few more. We'll go A2, we'll have a look at our second array that we created. There's our trusty two-dimensional array from before. Let's find the mean of this. So we go np.mean, A2, 3.633, beautiful. Now the mean would be if we added these up, 1 plus 2 plus 3.3 plus 4 plus 5 plus 6.5, then divided by the total number of items, so 6. We won't do that, but that's how you find the mean. If we wanted the maximum, you can use np.max. If we wanted the minimum, we can do np.min. If we wanted the standard deviation, we can do std for standard deviation. Remember, we can always press Shift-Tab, compute the standard deviation along the specified axis. If we pass no axis, it's going to do it over the entire array, which is what we want. Wonderful. And if we want the variance, we can do np.var A2. Wonderful. Shift-Tab, compute the variance along the specified axis. And now you might be saying, Daniel, what the hell is a standard deviation and what the hell is a variance? Well, variance, let's put a little comment here. What you need to remember is the variance equals the measure of the average degree to which each number is different to the mean. So we want higher variance equals wider range of numbers. Lower variance equals lower range of numbers. Beautiful. And now the standard deviation, the formal definition is standard deviation equals, standard deviation is a measure of how spread out a group of numbers is from the mean. The standard deviation is actually just the square root of the variance. So let's try this out. So we got np, there's another aggregation function, square root of np.var A2 should be equal to the standard deviation. So let's write this down. Standard deviation equals square root of variance. Shift and enter. There we go. These two numbers are the same. Now, if you'd like to look into a bit more of the math behind the standard deviation and the variance, I'll leave some resources in the resources section for you. Otherwise, in the next video, we'll see a bit more of an example of these two in practice. They're an important concept to know going forward in any type of data science or machine learning or statistical work. So let's take a quick break, play around with some aggregation functions that you've seen on some of the arrays we've made, or create your own, and I'll see you in a second.